Hi, in this video I show you a very complex topic in computing, and this is recursion. We say that recursion is a technique that simplifies a complicated problem by breaking it down into simpler subproblems. In computing, we have recursive method. We need to perform a task by calling itself to perform subtask. And after that, at some point, the method encounters a subtask that can perform without calling itself. So what does it mean? Let's look at this problem, right? We have this given these two integer number x and y. We want to write a method to calculate x to the power of y. This is x multiplied by x multiplied by x, etc. and y times. How can we do that? In recursion, we say that, we have a method, and this method performs a task by calling itself to perform some subtask. So for example, in here, let's say that I can call itself, I have the method power and the two input x and y. So now let's say that I can call a subtask by calling itself. So the power subtask may be y minus 1. The input is y and y minus 1. Y minus 1 is a subtask to the input y in here, right? So let's say that if I have this one, sub calculation, then how can I compute the final result? So we know that is we only need to multiply by another x. Isn't it? So we're done. This is the method perform a subtask by calling itself to perform some subtask. But now we need to add that some point we need to encounter a subtask that can perform without calling itself. In here we say that I can decrease y, and after that decrease y by 1, and after that decrease y by 2, and after that final, right? So for example, if the input is 3 and 5, in here y become 5, 5 minus 1 become 4. After that, calling minus 1 becomes 3, and after that, etc. And at some point, we say that, some point that we can perform without calling the method anymore. And what is some point? That is some point. Some point is that if y to 0, then we don't need to call, we don't need to do the subtask anymore. But we can right away, we can perform. So we know that x to the power of 0 always 1. And we're done. So this is one recursive method. Let's run it. And then the input is power of 3 and 5. Let's run it. And this is the result. 2, 4, 3, which is correct. How the recursion work? So in order to do that, right, let's run this example with the debugging and see. So you see that, right? Let's run and debug. First of all, we call power of 3 and 5. Let's step into it and see what happened. So at the beginning, the input is 3 and 5. Because y is not 0, so it call, right? So it's call a sub task, right? Now go in. Now it's called subtask and become 3 and 4, right? 3 and 4. Again, because y is 4, which is not 0, so now it's called another subtask with a 3 and 3, 3 and 3, and etc. Again, subtask 3 and 2, subtask 3 and 1, and again subtask 3 and 0. Now 0, because y is 0, now it can return already, it can compute already. It doesn't need to call itself anymore, but it can perform without calling itself. So because of that, right, the next statement is return 1. And because of that, now go back to 4 and 1. So because 4 and 1, right? So now because 4 and 0, just now we have 1 already. Now sub power become 1. And then it can return 3 multiplied by 1. And now it's become 3. It's return 3. So the subpower now, right? When calling this power, now it's become 3. Right? To look at, to help you to visualize it, right? We start with 3, 5. We go to 3, 4, 3, 3, 3, 2, 3, 1. After completing 3, 0, go back to 3, 1. After completing this 3, 1, go back to 3, 2. Continue. And then after that, now the x is 3, y is 3, so it's go back to 3, 3. Compute. Continue. And then go back to 3, 4. Continue. Come back to 3, 5. And now it complete its calculation. And as we return this, x is 3, subpower currently is what? 81. So finally, it returned the power 3, 5, which is our final solution. 3, 4, 2, 4, 3. So this is how this recursion works. So in short, right, it will call first one is call down. Yes, so slowly is get a subtask, get a subtask, subtask until there's no more subtask to call. What is it perform without calling the subtask anymore? After that, it go up, it go up, it go up, it go up, it go up until it solves the original problem.